Well, good afternoon for me. It's 3:10 p.m. Hopefully you're here for the community meeting for OpenSearch. Uh, I'm pretty excited today because we've got some really good news. We had two last minute presenters that very nicely volunteered to come in and talk about some cool stuff, as well as our latest release of 213. So I'll be getting to those in a little bit. But first, if you've been here before, you know we usually go over some etiquette before everything's gets going. So please do introduce yourself before speaking. By the way, I am Nate Boot, developer advocate for the OpenSearch project. I did not introduce myself first, so I have already broken our etiquette. Sorry about that. Please do mute yourself unless actively speaking. Cameras are optional. Questions anytime in the chat or audio. With the exception of if we have a presenter that has a preference between the two, let's try to honor the preference of our presenters so that they can give us the best information they have. And of course, if you're disruptive, we will remove you. Screen annotations have been turned off, so if you need to draw on the screen, you will not be able to do that. Profiles only show names. Only hosts or co-hosts can share their screen. So if anyone besides our presenters who needs to share their screen, we will have to grant you access to do that. And of course, additional co-hosts to ensure that disruptors can be removed properly. And unless you're a presenter, you've probably typed in a passkey to get here. And we've also turned off changing your name. So no one can be Nate B and say horrible, awful things. Savvy? We good? Awesome. So 2.13 is released. I'll have some slides on that coming up right after this. I wanted to throw out that OpenSearch Con Europe is coming to Berlin. I know I mentioned it last week. Let's get people registering. If you have not registered yet and you intend on going, we would love to see some registrations come in. Historically, they come in pretty late. I think that's just the nature of the beast for conferences. People tend to register in those last 2 weeks or so. But yeah, help us organize the best conference we can and register as soon as you can so that we know who to expect and how much food to get and all that stuff. If you're going to be in Seattle, we're having our first Seattle user group for OpenSearch on April 15th. Hopefully someone has the link to that because I forget the name of the building that it's in. Oh, and we have started to announce sessions. Thanks, Chris, for OpenSearchCon Europe. I think we've got 6 listed there and a handful of the related speakers, as well as the Open Source Connections workshop that will be going on there, which will be quite some fun. I do recommend it. And of course, Open Source Summit, North America in Seattle. Just after our user group, that ought to be fun too. We are in booth P2. If you're headed that way, please do come by and say hi. We'd love to shake hands. I'll trade you some t-shirts and stickers for whatever swag you've got going on. And looking forward to seeing you there. So let's talk about 2.13. There's been a handful of performance enhancements. The core was improved for improved performance and resiliency and instrumentation. By the way, the release date was April 2nd. I think we did get it out on the 2nd of this month. This IO-based admission control is a really cool feature because it has mechanisms that protect against spikes or increases of capacity if your cluster's IO breaches a defined threshold. So I think that's pretty cool. Automating configuration of search and ingest pipeline resources with a new flow framework. Now, I think what our 2 presenters that we have up second today will be talking to us all about that. It takes away a lot of the manual labor that has to go on when you create a neural search pipeline and uploading a model and registering the model and all of that stuff. So I think they've added a lot of usability improvements just by kind of creating this this flow or this wizard, I like to call it. More AI connectors. I believe we previously had the ability to connect to OpenAI to do AI inferences. This includes a couple of extra templates that let you automate things like OpenAI, Amazon Bedrock, and Cohere. Uh, Optimizing document ID lookups, uh, using the Bloom filter data structure, you can actually have some throughput improvements up to 30%. So there's a lot of speed and performance improvements, along with some usability features that I'm particularly happy about. A new agent framework for automating machine learning tasks, support for guardrails, using user-defined regex rules. So I haven't played with that yet, but my instinct tells me it's making sure that your inferences don't break some kind of content policy or something like that. Aggregations to hybrid search results, cross-cluster monitors to enable management of alerts across clusters. James, Chris, did I miss anything out of that? I've got a couple of no, I got it.
I think we should head right into those presentations.
Yeah, let's make it happen.
Excited for those.
All right. OpenSearch super friends Ken and Oscar from Trace Tester here. They're going to be talking about extending the value of OpenSearch-based OTel visibility to testing. And then also about the flow framework, we've got Josh and Oase here to give the following presentation. And I think without any further ado, let's hand it off to Ken and Oscar, and let's have you guys do your thing.
Sounds good. How's everybody doing?
I'm excellent, thank you.
See if I can show a screen. Everybody see a screen?
Loud and clear.
So I'm gonna go to the second slide pretty quick so that I don't break the first rule of the community meeting. So we'll just kind of skip past this, but we're basically we're gonna talk about how if you're putting traces into OpenSearch, how to better use that in your test environments proactively. But so we don't break any rules, I'll introduce myself. Ken Hamrick, founder, currently in Mountain Home, Arkansas. I traveled over here for the totality, and it just so happens that our lead software engineer, Oscar Reyes, was also in the paths at totality, and he is in Turin, Mexico.
Yeah, actually, yes. Hello, everyone. Thank you for having me here. Actually, the NASA shows Torreon as the central kind of focus point for this eclipse. We have them over here in the city. It was pretty nice. A bunch of people uh, came to see the eclipse. It was pretty nice.
I'm still seeing spots, but otherwise I'm in good shape. All right. So let's do it. I've got like 7 slides, and then we're going to show some live software. Just kind of talking about how we got to where we are. Back when I was doing role work, we had monoliths. We thought we were kind of fancy because we had a 3-tiered system. We had a front end, a API, and a back end, but it was pretty easy to troubleshoot. You could look at code, you figure out what was going on. As things started getting more complicated and we moved towards cloud native microservices, you can't tell what the hell's going on. And that led to the advent of observability, and people started using there are different standards for distributed tracing in particular. They kind of coalesced into a standard called OpenTelemetry that's all about 3 metrics: tracing, metrics, and logs. We're going to talk about traces. I do a disservice if I didn't quickly say what is a distributed trace. It basically shows you the lifespan for a single transaction, all the services it goes through, all the steps, and each of the steps is called a span. And inside each of the spans are what are known as attributes, which has characteristics of exactly what happened in that span, like how long did it take, what was it, if it was a HTTP request, what did it reach out to? Was it a post or was it a GET? Did it get a status code? And what was that status code? So distributed tracing came along. It made it easier to troubleshoot systems that were in prod. So when things broke at 2 in the morning, you could get on and see the trace, figure out what was going wrong. But it was really only used in prod. So it's a reactive technique. And I've carried I'm old enough to call it a pager, but I've carried a pager or a phone my entire career, except for like the last 4 years. And I've been waking up at 2 in the morning, and that sucks. So it's much better if we do things proactively. And in system, in software, we usually are proactive by testing things. But our techniques that we're using today for testing are not that far removed from when I was writing code back in the 2000s. Black test, we hit a API, we get back a response, we say it passed or failed. And that was great with simple systems, but it's hard to say, in this microservice, there's 20 microservices involved. Great, it failed. Why did it fail? Or why is it slow? And most, we don't blame people, but ultimately, who can I call to get this thing fixed? And if you actually go to write full tests to fully test a flow that might be doing multiple actions, like, all right, when somebody logs in, we need to set up an account, and we better send them an email, and we better provision this in the database. If you really are writing a test that goes across the entire flow, it's really hard. You end up having to instrument it. It takes a long time. You've got to know the full system even to write that to a test. So you end up being a senior engineer that's been there for a while and knows the system. I needed to have my Eclipse glasses on so I could black out everything. But when you can't see anything, it's hard to figure out what you're doing. It's hard to test things. So what does trace test do? It allows you to see inside the black box. And it does that. I said a minute ago, typically if you're going to do roll end-to-end tests, you need to instrument your code, but you've already done it. If you're using OpenTelemetry and distributed tracing, you've already instrumented all your code. And our thesis is you should leverage that as part of your tests. And if you have a trace with every test you run, it's going to be easy to see what happened, what failed, which system it is. So you can go back to that team and say, hey, we're not pushing this through our CI/CD pipeline because it's got a problem. Being able to build a test, and we'll show you this, build a test based on the actual observed flow makes building test easy. You can check both the functionality and the performance, and you can test things before you actually deploy. So will it work with your current stuff? We work with multiple different existing test frameworks, Cypress, Postman, Playwright, K6, and some others. I think Artillery's coming out next week. And we work with your current observability solution. So whatever you're storing your distributed traces in, we directly connect to OpenSearch. And we can show you that in a minute where the setup screen is. So you basically log in trace tests, set up an organization and an environment, and then you give some connect information for OpenSearch, and OpenSearch will then, we know how to get the trace from OpenSearch at that point. So that's about it for the slides. I would like to go through and show you a couple different demos based on a system that Oscar wrote, and it's called the Poke Shop. And it's all about Pokemons, and it's got 2 microservices. One is a Node.js API, and one is the process that actually does all the work. And in between them, there's a RabbitMQ system. And it talks to a few different pieces of technology, Redis and Postgres. And it also reaches out to pokeapi.co, which is external API. So we're going to show just a basic creating a test for a minute, just a basic API test. So I'm logging into tracetest.io. We go to test. Make the screen small so I can see. I'm going to create a new API test, and I'm going to hit a API endpoint, and I'm going to cheat so I don't have to type. I'm gonna do it. This should look a lot like Postman. I'm gonna do a post against this API endpoint. And Oscar, can you give me a number? 1 to 100?
6.
6. Okay. And I'm gonna run this test. So if you've ever used Postman, this can look very familiar. We're testing an API. We hit it, we get back a response, which is great. We get back a status code, but you'll also notice something different. We're looking for the trace for this specific transaction, and we've got the trace now. So what can we do with this? Well, we can start building up our test. I think the most frequent API test in the world is let's check the status code. We expect this to work. Let's make sure it does return a 200 when we run this. So we're going to say we expect the status code to be 200, and we can save this test. And that's great. And that's something every single API test tool in the world could do. What they can't do is show you what happened inside the system. We can see here the first microservice that is the API, receives the API request, validates it, puts it on message queue. But then I can drill down further and see that the second microservice pulls it off the queue, looks to see if it's in the cache. It got a cache miss, reached out to external service. Let's look at that a little closer. We did a get against the pokeapi.co. We passed it the ID of 6, and we got back Charizard, which I probably am not saying right. So it's an external service. We don't control it. They could change the interface. It could be down. So it's a good thing to cover in a test to make sure it is working like we expect it to. So I'm going to add assertion and say, when we call this transaction, when we reach out to this external service, we expect to get back Charizard. And I could name it, check external, and I can save it. So that's an example of a test that normally would be pretty hard to build. You'd have to instrument your system first off. Your test wouldn't be a simple black box test. It'd have to either reach out to the database or somehow you'd have to instrument around that external call. With trace tests, since we're using the distributed traces you already have set up, it's really easy to create the test. And I'm gonna go up to the save the test, go up to automate tab and look at the test definition. Here we see we've got a trigger that is of type HTTP. We did a post against that endpoint. We passed it 6. And then we can see the 2 assertions. We checked to make sure the status code was 200. And that when we called this external service, we got back Charizard. So that's an example of building a test and trace test. And it's quick. You can see what you're doing. And when a test fails, it's going to be easy for the engineer to come in. They're going to see this. They're going to see one of these spans failed. They're going to click into it, and it's going to drill down and show them exactly where the failure was. Let me go back to the slide for just a second. So I think the next thing I'd like to show, if you would, Oscar, is I wanted to talk about sorry, guys.
End to end.
Yeah, let's talk about the end to end.
I can do that if you want me to.
You want to do it? Yeah.
Yeah, please.
Oh, so Ken, this
Yeah.
is really awesome. This is Lior. Hi.
Hello. Good to see you.
Nice to see you. So would you prefer asking question now or at the end?
Go ahead. Make it more interactive.
Yeah. So my first question is it possible to add, like, to change the hotel specification collector as part of the testing? So let's say I see there's an issue with one service, but I know it's not collecting enough information. So what's the recommendation?
Yeah. I think so. If a system's not putting the information into a trace, then you want to improve your tracing. So you need to go change. If it's manual instrumentation, you need to go add more manual instrumentation. So there's no magic. There's no magic there. I think a good side effect of building tests based on traces is you tend to make traces better because you need to write a test. You don't have the information you need, so you add it. And then when someone is troubleshooting something in production, they've got much richer instrumentation. So there's kind of this cycle that starts happening where you're improving your traces, you're building tests. It just kind of keeps making your instrumentation better and better.
I see. And to continue that, are you at all changing the collector pipelines, or are you using just what the customer?
Yeah, we've got two. Go ahead and share your screen. I'm gonna direct you for a second. If you don't mind,
Sure.
go to settings. We've got two ways to get traces from systems. We have systems that are super cool that we can directly integrate with, and OpenSearch is one of those. So when you set up trace tests, you come in here and you basically just fill in a few pieces of information about your OpenSearch instance, and you hit test connection, and we work, and you're off and running. For ones that do not support directly reaching out to a system with a parent trace ID and getting back a trace, we show you how to use the hotel collector to set up a second pipeline. So you can let's say you're using pick a vendor, Honeycomb. You can continue sending all your traces to Honeycomb, but you can put a section in the pipeline that says, hey, when you see a trace trace, also send it to trace test. And that way we get the information we need.
Yeah, I hope I'm doing a good kind of good job of following you on that. One thing that I want to add to the first half of the question is that we also have an analyzer for traces. So in that case, if you want to take a look, let me see if I have one open. Yeah. So there's some spoilers over here, but we have a trace section that what it does is that allows you to and your team to have rules based on the traces that you generate. So it has this loop of your team adding traces, looking at them, analyzing them to see how good they are, and then going back again and trying to improve that number. So we're kind of following an approach similar to Lighthouse, Google Lighthouse, where it just kind of analyzes the whole trace and gives you an output of this is a really good quality depending on the semantic conventions and the defaults, that kind of stuff. And yeah, your team can also use that to improve the tracing.
Yeah, that's very cool. So next option is what prevents using that not only for testing but also for monitoring system?
Yeah, just I think our purpose for trace test specifically is to be a test tool. So development wise, if we're going to try to be an analytics tool and look across tons of traces, that's work that's been done by, OpenSearch has an interface to do that. All the vendors do, if I can go down the list, and we just didn't see a point in reproducing that work. So we are much more interested in adding visibility in your test environment, and then for production troubleshooting, use whatever backend you're currently using for analyzing traces.
Great, thank you.
Sure thing. So let's move on to the next topic. As Ken mentioned, we also have this other layer. I really like this to be said like something like, but there is more, and there is more because we are just keep adding new stuff. And this is the interaction with end-to-end tests or end-to-end frameworks. And today I'm going to be showing you our Cypress integration. So I really like this concept of breaking the chain of blame. And as myself being worked on as a front-end developer for a while, having just those tickets on those bugs sent to the front-end team at the beginning without knowing if the service is failing or if it's something in the front end can be really annoying, right? So with trace test, what you can do is pretty much integrate your Cypress test with our telemetry, OpenTelemetry, and our tools, so you can gather all of the traces starting from the front end. So you are now not only looking at backend services or systems to be instrumented, but also the front end with all of the JavaScript tools and the standards that you get. And in this case, what you can see is everything from the document load, where you can see how fast the resources fetch or the document fetch. You can also add some things for web, I don't know a specific name. You can check like first render or things like that and see that those directly in your trace. But not only that, you can track the user behavior in terms of clickings, key downs, any type of events that happen in the front end, and also tie those up to the rest of the system. So this is pretty much an expanded version of what Ken showed showed instead, the only difference is that it has the front-end information as well. So you can see that at some point a click or an event that happened on the front-end trigger the import and the import span or service. And then you have pretty much what can show you, which is the validated request, sending the message to the queue, and then the rest of the services picking that up. And so that means that from a front-end test, you can have the same test specs and validations that you will have in a fully in a just an HTTP request, right? So this is why we're kind of always trying to improve and have better ways for teams to include trace tests and OpenTelemetry to your tool set. So yeah, we have that. So how does it work? I'm just going to run. We have the PokeShop API that we pretty much use for all of our examples. And we have also included Cypress tests. We can share a link for this example and the documentation as well. But if you run npm run ci run, a lot of run being said, and that was going to execute the Cypress tests alongside our stuff on the trace test side. So what happens on the UI? If I go to the runs, if I go to the wrong section, you'll see at some point that something is going to pop up over here. Okay, I see this one, and it's going to be calling out the different specs that I have here. Create a Pokemon, deletes a Pokemon, and imports a Pokemon. We also have a bunch of metadata for you, like the branch, the tool that was used. You can even, by clicking here, you'll get directed to the documentation about Cypress, so you can see more about it. But what I want to show you is like for example that works 100% with no issues, it will look something like this. You have your 3 tests, and each of them will generate their own trace, and you can take a look and add new specs and kind of keep the loop, right, of pretty much what we call open or trace-based testing, right? That is just you can just keep adding traces and adding more information to it and keep adding assertions. So we're going to be going back to the one that we have over here, which it has 2 specs. One for that checks the all spans are returning to 100, and this it's collecting the or matching this span that is all the way to the bottom of the services. So the one that goes to the PokeShop API, the pokeapi.co. You can see this one over here. And the second one that we're checking is all of the databases are really fast, right? So in this case, that this is less than 2 seconds. And we can see we're matching multiple spans with this. So we're saying, give me all of the spans that are type database. So in this case, even if it's Redis or if it is Postgres, it will be matched and it will be asserted against with the data that was generated. So we also have one that failed over here that is delete Pokemon, and it failed because this is really slow. We're expecting it to be fast, 200 milliseconds, and it went over that. So you can see over here as well. Just to move on, I'm going to show you a quick, like from the code, how this is going to look like. Just really quick, we have the import method calling for the trace test Cypress package. This works with both TypeScript and JavaScript. And next thing is you can have also the definition that can show you in the UI be part of your code base. So if you want to have like this based on code, you can also do that and start generating these strings or these objects based on the things that you want, like from TypeScript on script based. Then it's generating the trace test instance. Once you have that instance with the API token, then you need to capture the document that was going to be used for the tests. This will create a trace parent, and all of the spans will be generated based on that trace parent from the front end to the backend services. And the last thing is a summary. The summary is optional. If you want to break your Cypress test based on trace-based tests, you can enable it. But if you don't care about trace-based tests to affect your pipelines and you just want to kind of have a side effect or a second look of them based on the UI, you can also just remove this and it will work as expected. So you have those 2 options. Yes. So before, this is all we have for the end-to-end. Next thing that I want to talk about, I don't know if we have a question. So
Yeah, I think on the load test, I think we'll just talk in the interest of time to keep things shorter.
Yeah.
Yeah. Why don't you just say what we do and then I want to share one last thing.
Yeah, I think we have something around here. Give me 1 second. So we support K6 and Artillery. Those are our main tools that we use for load tests where we have a specific more plugins and extensions for these two tools, one for TypeScript, one for Golang, where you can create your own scripts and generate load tests based on trace tests. So the services trigger the HTTP request to your services. We gather the telemetry data, and then we run assertions over them. So you can see this is a run group that has 20 requests that were executed from the same K6 script, and all of them are executing a trace-based test called adds a Pokemon. So if I go here, I can just see the trace generated over here with a bunch of specs on the right. And we have documentation for you guys, and we have videos, we have a bunch of stuff around this that you can take a look if you go to the documentation site.
One last thing, Oscar. Click
Yeah.
that. We're asked to share the open trace test is included in the OpenTelemetry community demo, which there's a version of it that works with OpenSearch directly. Actually, is OpenSearch part of it now, Laura? I think OpenSearch might be. For a while, it was the default.
Yeah,
back.
we forked the OpenTelemetry demo, and now it's formal as part of the OpenSearch project.
And so part of that is going to be about almost a year ago now, the OpenSearch project, the OpenTelemetry demo, they're having trouble, or people are contributing a lot of code, is breaking things, and they said, hey, we need to embed trace test in this exactly for this reason, so that instead of changes getting into production and breaking things, they could catch problems on the front end. And the link I just posted talks about that experience from one of the OpenTelemetry maintainers.
So in practice, you can use this also for sort of baseline compare. So you have a set of tests that if you know it doesn't pass, then it's
Actually,
that's really
and
useful.
a lot of times people will build tests for their, start off with your golden pass to say these are really important things that the system needs to do reliably. They'll take it, put it in their CI/CD system, which we've got like GitHub Actions and all that kind of stuff. So it's easy to put into your production flow, or your staging flow before you go to production. And how would I put it? Typically, distributed tracing is being used by your SREs or your DevOps people, but the developers don't get much value out of it. Your QA people don't get much value out of it. By using trace test, you start distributing the value across all the teams, and everybody starts caring about it versus just a select group of people caring about it.
Yeah,
that's really awesome.
Thank you.
Yeah, super cool. Does anyone else have any more questions for the trace test team here? No, awesome. So we're in the clear. Before we move on to thank you very much, Ken and Oscar. I appreciate your time and your effort as always. Before we move on to the next presenter, I've noticed and have heard that there are a lot of RFCs on our GitHub that aren't, we could use more feedback on. And I think if I could share a link for our newest GitHub RFCs, thank you, Chris. We could use the community's feedback, and this is one of the ways in the broad spectrum of things how people can contribute and really assert your stake in OpenSearch. If you really need something to be implemented a certain way, or a certain feature prioritized, or any feedback you have to have for these RFCs is welcome and appreciated. And with that, I believe I will hand it over to Oase and Josh.
Okay, thanks everyone for joining. So in this presentation, we wanted to talk about the new plugin OpenSearch Flow Framework, which we just launched in OpenSearch 2.13 release, and just wanted to give you an overview with a pre-recorded demo which we have, which will explain you guys about like how we are trying to automate a couple of ML offerings which are there in OpenSearch. So before that, to begin with, like currently with all the new Gen AI boom going on, every user wants to have some kind of AI feature in their application through OpenSearch or through any way. So what we are trying to do here is like in terms of doing the whole complex setup of ML right now in OpenSearch, it becomes very complex. I believe most of the questions which we get in the OpenSearch ML Slack channel as well are related to like the setup questions, like how things are getting complex and how to make it more simpler. I believe Nate also wrote a blog post a few days back regarding how to do the neural search and trying to explain like how to register a model, everything. So to overcome all this kind of thing, we started building this plugin called as OpenSearch Flow Framework, which would try to simplify the whole setup for you. I'll try to keep this introduction short because we have a pre-recorded demo as well for you guys. So to start with this, we have this is the agenda for the presentation. I'll talk about the introduction and then I'll explain through one of the example and then we'll show a quick demo. So yeah, so what is Flow Framework? So right now, if you see in setting up any of the ML offering of OpenSearch, let's say hybrid search or neural search or semantic search, there are a couple of things which you have to do beforehand before actually using the search. It's like registering the model, deploying the model, and then creating those connectors for the remote models and creating ingest pipeline and probably creating a KNN index as well. So to simplify the whole experience for the user, this plugin would take care of simplifying the complex setup by making those transport API calls directly through our plugin, through a transport client which we have through ML Commons right now. In terms of that, users just have to use one single API so that they can directly do the whole complex setup for us, and later on they can perform the search using the search pipeline or the hot path search API. Apart from that, this plugin also provide couple of automated templates for you guys so that you can just use it directly. So those automated templates can be like semantic search using Cohere embeddings. Then we have hybrid search, multimodal. You can set up the whole open AI chatbot through the template with just one API call. So a couple of things this plugin is trying to solve right now. Now I'll explain the current ML setup for semantic search. How does it work? So for semantic search right now, you have to create a connector for remote model with some pre and post function. You have to register an embedding model using the connector ID, which is created in the step one, and then configure an ingest pipeline to generate those vector embeddings because that will help us to search on the vectors which we have created. And after that, you have to create a KNN index and add the pipeline creator about. So you see like how the complex setup can be for a basic functionality of it. So now how can Flow Framework help with this? So to see, we have a couple of APIs right now available in Flow Framework. One of the APIs is like the workflow API in which you can directly pass a use case. So we have some automated templates, which I'll show you in some time. One of the use case is like semantic search with Cohere embedding query enricher. So in this use case template, we have done the whole provisioning for you, like how the template and the set gonna look like. And in the payload, you just need to pass about just the dynamic values which is required for the template. Let's say the credential key, because we don't know that. You need to pass that. And apart from that, even the index name, if you don't pass that, then whatever the default value we have in the defaults would be taken. If not, then it will be taken from the whatever passed from the user in the payload. So this way, you are just passing the dynamic values and using this one API call, you're doing the whole setup. Now, after calling this API, OpenSearch will return you a workflow ID. This workflow ID would be later can be used through the status API to see which all resources OpenSearch has created for you for performing the semantic search for Cohere embedding and rich. Moving on to the next slide. Yeah, so these are I'll share this default and sample use case. We have a couple of default and sample use case right now. Not fully, but to begin with. So if you see here, we have the substitution templates, a couple of like you can have multimodal search template, hybrid search, neural sparse log by encoder template. And these are the defaults for those specific templates. Like if I open one of the one, let's say this one, these are the default values for this. But if those values are provided in the API itself directly, then this default values will be overridden. And then we have some sample templates as well. Like, let's say if you want to create an observability chatbot, you can just use this template directly. And if you want to just deploy OpenAI model, you can use this template directly. So these were some additional default and sample use cases which we have right now, and we plan to add more in the future. But these were the immediate one. Now moving on to the demo, which my colleague Josh has recorded. I'll just play it so that we can quickly watch it. And this will give you a little bit more introduction and the live show of Flow Framework.
For those of you who are unfamiliar with what Flow Framework is, at a very high level, Flow Framework is simply a chaining mechanism for OpenSearch APIs. And we facilitate this chaining through a directed acyclic graph defined in our templates, which you can see here. So our templates consist of a list of nodes, which are our APIs and their various inputs, and edges, which dictate the order of execution. And so by topologically sorting this graph, we ensure that each API has the necessary inputs provided by both the user and previous API responses. And through this chaining mechanism, we can reduce the execution of several APIs to just one click. And coupled with ease of use improvements that we've made in 2.13, such as having substitution-ready templates, we can reduce the complexity of configuring and executing this graph in a substantial way. So how can this capability help us? The main issue that Flow Framework attempts to address is that the current process of utilizing machine learning offerings in OpenSearch, such as semantic, hybrid, and multimodal search, often involves users grappling with complex middleware and pre-processing tasks. So this includes configuring and creating connectors, registering remote models, configuring and registering agents and tools. Each represents a significant overhead to understanding how to correctly configure these components and in what order to create these. In practice, if a user's goal is to just leverage and compare different large language models, configuring and setting up the necessary infrastructure is both a time-consuming and, most importantly, error-prone process, which can be detrimental to the overall user experience. And so now let's take a semantic search use case as an example to explore the difference in user experience of setting up this middleware. And let's start without Flow Framework. The very first step that we need to do is to create a connector. Here we're creating a connector to a Cohere embedding model. And we configure the pre and post process functions and pass in the necessary credentials. Go ahead and execute this here. Now we have our connector ID. The next step is we have to take this connector ID and register a remote model for that embedding model and deploy it to our cluster. Now that the model has been registered and deployed, we can go ahead and create our ingest pipeline. This ingest pipeline will take in a model ID. It's a text embedding processor, which allows us to generate vectors on the documents that we ingest. So now we're just going to go ahead and create this. The next step is to configure a neural query enricher search pipeline. And this allows us to set the default model ID for a neural search request that we'll send to our index. I'm going to go ahead and create this as well. Now, finally, we're able to actually create and configure our index. Here in this index configuration, we're setting our default search and ingest pipelines. And we have to ensure that our mapping properties correspond to the field map of our ingest pipeline here. So let's go ahead and create this index. And finally, we're able to ingest data and begin testing the infrastructure that we've created. Let's go ahead and create this document and invoke search against our index. As you can see, it's successful. So now let's say in a separate case that as you begin to ingest data to test your semantic search infrastructure, you realize that the pre and post functions of your connector are invalid. And now your only way to fix this issue is to create a whole new connector here, which gives us a new connector ID, which forces us to register a new remote model and further take that new model ID, update our ingest and search pipelines. So now this is just one example of an error, but as you can see, management of middleware can represent significant overhead to the user's underlying goal. These errors compound over time, and in the end, it just makes management of this middleware a hassle. And this process can also be convoluted to users and be detrimental to their overall impression of using OpenSearch as a platform to host and leverage machine learning capabilities. So now let's explore what this entire process looks like using Flow Framework. In Flow Framework for 2.13, we've provided default templates for existing search use cases, such as hybrid, semantic, multimodal, conversational, narrow sparse search, along with query assist. And so in our default templates, we can see that we have a semantic search use case with a cohere embedding query enricher template. And this just requires an API key for us to use. This is an example of the request format. And so let's go ahead and actually create this right here. And this gives us a workflow ID. We can actually validate that our resources have been created successfully by using our status API. And this will show us exactly what resources we have created. And you can see that we've created a connector, registered a remote model, deployed it, passing that model ID to our search and ingest pipelines, and finally creating our index, all in one click. And at this point in time, we're able to begin ingesting and search. And overall, the difference in experience is substantial.
So yeah, thanks Josh for recording the demo for us. Really look good. Now, the next steps for us is basically to create a user-friendly drag and drop front-end interface just to accommodate all this backend template which I've shown you through the template, so the user doesn't have to go through all this template configuration and everything. And we have already posted our backend RFC, our front-end RFC, and we have a GitHub repository out. And day before yesterday, we also have a blog post also out. So do check it out. Let us know on our RFC if you have any questions or if you want us to automate something else as well as part of the complex setup which we have in open source. So yeah, that's all.
That's awesome. Thanks so much for your time, guys. You mentioned RFCs, and I just wanted to take this opportunity to mention, don't forget to visit the link that we pasted before if you want to share your thoughts on an RFC. I know that we could use a lot of that input there. And so this is a great opportunity for you guys. Hey, you guys have met Chris Verdane, right? Awesome. Well, I wanted to, are there any questions for Oasis or Josh? All right. Well, I think we are at time. I wanted to leave you guys, leave everyone with a parting thought. My grandmother, she hates her stair lift. And I keep asking her, why do you hate it so much? And she says, well, it's driving me up the wall. Okay. And that is your wisdom from the OpenSearch community meeting, April 9th. Thanks, everyone.
Thank you, everyone. Bye.
Bye.
Thank you, guys.